Okay, so the main focus of this second lesson in this module are a couple specific things that we can do when factoring. Okay, so factoring using a GCF, so that's a greatest common factor. A greatest common factor is something that we should always check every problem for. So in the last set of notes and practice, I wasn't having you focus on a GCF because we haven't learned it yet. But from here forward, you should always, always, always check to see if you have a greatest common factor that you can factor out. So first we just need to work on finding a greatest common factor. So finding a greatest common factor is very simple. You just have to know what the biggest number that divides into both of them would be. Okay? So if you're ever stuck, usually you can look at it and tell. If you ever get stuck, so like say we're stuck on 22 and 30, the easiest thing to do is to take your smallest number, so in our case 22, and find the factors of that, which is actually pretty simple, right? We have 1, oops, let me get my pen out here. We have 1 and 22, then we have 2 and 11, and that's kind of the end of that, right? So those are the 4 factors that we have for 22, and then I look for the biggest one that divides into 30. So 22 does not divide into 30, 11 does not divide into 30, 2 does divide into 30, so my GCF is 30. So you're just looking for the biggest number that divides into both of them. It's really simple when it comes to variables as well. So remember you're thinking what you can take out. So if I look here and I simplify here, I see x to the 4th y and x squared y squared. So I want to think about what I can take out of both of them and still be fair. So in this first term here we have 4 x's. This one we only have 2 x's. So if I want to be fair, I can take 2 x's out of this and 2 x's out of that. So part of my GCF would be x squared, okay? And then with my y's, I have a single y here and 2 y's there, so to be fair, I can only take out 1 y, so my GCF would be x squared y. So now let's put it together, okay? So let's put numbers and variables together, and let's look at what it looks like, because factoring, remember, we do have something left over after we find a GCF, okay? So let's identify my GCF. So the biggest number that would divide into 5, 10, and 25 would be 5. Oops. So we have, let me write up here. My GCF is 5, and then I have a to the 3rd, a squared, and a. So I can take an a out of all those and still be fair. So my GCF is 5a. So in my answer, I'm going to leave 5a out front. So this is actually factoring it out now. And then I'm going to divide, because remember factoring is all about dividing, 5a into all 3 of those terms. Okay? So now in my first term, the 5's cancel. On the a's, I have 3 on top. Take away the one that's on bottom, I'm left with a squared. Okay, the second term, negative 10 divided by 5 is negative 2 or minus 2. I have 2 a's on top. Take away the one that's on bottom, I'm left with a single a. And then on the very last term, 25 divided by 5 is plus 5. And the a's cancel cleanly. So that is my factored form. Now moving forward, right, we know that sometimes we can factor stuff like this in the middle. Okay? So now we have 3 terms. I'm looking for what multiplies to 5 and adds to negative 2. So what multiplies to 5, let's come over here and find what multiplies to 5. So 1 and 5. We have negative 1 and negative 5, and that's it. Now I find that neither one of those pairs adds to my negative 2 in the middle, so I am done. So you always have to check for a GCF first. Sometimes you can, sometimes you can't. Then after you take out the GCF, then you check and see, can I do any more factoring? Sometimes I can, sometimes I can't. So those are just kind of the steps that you have to go through. So on the second problem, number 6 here, my GCF would be 6h. So I'm going to divide each of these by 6h. Okay, I'm going to throw my 6h out front. So 6's cancel, h to the third, take away an h on bottom is h squared. Remember, that's just subtraction on the exponents. 12 divided by 6 is 2. And then h squared, take away an h is just an h. And then negative 18 divided by 6 is negative 3. And my h's cancel there. So there's my answer that far. And then I check, can I factor any more? So I bring my negative 3 over here. I say, okay, for negative 3, I can do negative 1 and 3, or 1 and negative 3. Those are the only factors I have. And I want to multiply to 2, or excuse me, I want to add to my b value in the middle here. So that b value is 2. So the pair that adds to positive 2 would be negative 1 and 3. So this GCF comes down and stays out front. But then inside this trinomial right here, remember I put 2 sets of parentheses. My h squared breaks into h and h. And then my 2 factors back there are negative 1 and positive 3. So now that we have 3 pieces, we have the GCF that's out front, and then the 2 sets of parentheses that trinomial broke into. So remember, always check GCF first. Sometimes it will happen, sometimes it won't. And then you check to see if you can factor more after you take a GCF out. Sometimes you can, sometimes you can't. All right, let's go to the second page. So the second page is a different concept. It deals with solving. So some of your problems that you will see will have an equal 0 on the end. Okay, so equal 0 is pretty easy to deal with. It's just asking us to now solve the problem. So I factor as much as I can. These first 2 problems right here are actually factored for us. So I factor as much as I can, and then I solve. And the way that we solve is we take every piece and set it equal to 0. Because if I'm looking at this expression right here, a 0 sitting out front would wipe everything out and make it 0. Or if I can make this inside of the second parentheses 0, then it would wipe out whatever's out here and it would make the whole thing 0. So I have an answer for every piece that I factored out. So in my case, I have x here and I have x plus 5 here. So I have x could be 0 or x plus 5 could be 0. And I know I say or, but you do have to have both. Luckily for us, this one's already solved for us. Okay, this one just takes a little bit of work. Subtract 5 from both sides, and we see that x equals negative 5. So I get 2 answers there, okay? Looking at number 2, I have 2 pieces here. I have c minus 2 and c plus 1. So c minus 2 could be 0, or c plus 1 could be 0. So add 2 to both sides. C could be positive 2. Subtract 1 from both sides. C could be negative 1. So there are my 2 answers. Okay? So the only thing we have to do on the problems below is factor first. Okay? So we need to factor first. So let's look at number 13 together. Okay? So I check for a GCF with no number sitting out front here. I can't take a number out. And with no G on this last term, I can't take a G out. So there is no GCF here. So then I'm finding what multiplies to C and adds to B. So multiplies to C. So I need 40 over here. I need to find factors of 40 that are going to add to negative 13. Okay, so I have what? For 40, I have 1 and 40. That's not going to help me. I have 2 and 20. That's not going to help me. I have 3 doesn't go in. 4 and 10. That isn't going to help me. And then I have 5 and 8. And 5 and 8 add to 13. Remember, I need negative 13, so I want the factors of negative 5 and negative 8. Okay, so this trinomial is going to turn into 2 binomials, right? 2 sets of parentheses. The g squared breaks into the g and g. And then the second spot's filled in with my factors, so negative 5 and negative 8. Okay, the equal 0 part just kind of travels down with us. Now that we've factored, now we have to solve because of the equal 0. So if there is no equal 0, there's no need to solve. When there is an equal 0, that's when we need to solve. Okay? So now I set up my equations. G minus 5 equals 0, or G minus 8 equals 0. So add 5 to both sides. G is 5. Add 8 to both sides. G is 8. There are my 2 answers there. All right, let me pick out a couple problems for you here. Let's go ahead and do let's go ahead and do 15 and let's do 18. So a trick that I'm going to show you on 18. Notice that all the problems that we've done up here were all equal to 0, right? So 18 is not equal to 0. We can do a very simple step and make that happen. So if I just subtract 8 from both sides, then I would have t squared minus 7t minus 8 now equals 0. That's how we make that equal 0 happen, and then you just move forward from there. So go ahead and pause, finish 15 and 18, and then you can play when you're ready for me to go over them with you. Okay, so for number 15, I check for a GCF, and there is not one. So I pull out my C and say what factors of that are going to add to negative 7. So 10 is fairly simple. I can have 1 and 10, negative 1 and negative 10. Neither of those add to 7. I could have 2 and 5, or negative 2 and negative 5, and there is my pair that adds to negative 7. So it's going to be 2 sets of parentheses. Leave your equal 0 on the end. The w squared is going to break into w and w, and then my back spots are going to be negative 2 and negative 5. Because of the equal 0, I have to set up equations. So I add 2 to both sides. So w equals 2. Add 5 to both sides. W equals 5. So remember, the only time we do this solving part is when I see the equal 0 right here. Okay, we already went over the first step of number 18. We needed to solve and get y by, or excuse me, make it equal to 0 first. Okay, so now I factor it like I normally would. I check for a GCF. There's no number. There's no variable that divides into both of those. So I pull out my C, negative 8. Find the factors of that add to negative 7. So I could have negative 1 and 8, or 1 and negative 8. And I've already found the pair that adds to negative 7. So that's going to become t plus 1 for the positive 1, t minus 8 for the negative 8, equals 0 tells me I need to solve, so t plus 1 equals 0, t minus 8 equals 0, so subtract 1, and t is negative 1, add 8, and t is positive 8. There are my two answers.